Good morning, my wonderful scholars, my fourth grade scientist. So, we've been learning about sound and energy. We've been learning about sound energy. Vibrations that pass through matter. Sound can travel through solid, liquid, and gas. Quick question, class. Can sound travel through empty space? I'll give you some wait time. Correct. Class, no, it cannot. Sound cannot travel through empty space. We also learned about how sound travels through frequency and wavelength, the crest, the trough, and what cycles are. Crest, meaning the sound waves, are the peaks. Trough, meaning the down part. So, crest, trough, cycle. So, today we'll be learning about pitch. Pitch is how high or low something sounds. You ever heard someone say, "You're not in perfect pitch," as someone was singing? Right. So, the material of an object make the difference in pitch, along with the size of it. Right? So, pitch, the material of an object making the sound, and its size and shape affect the pitch you hear. It's all about what you hear. So, let's just take this bottle, right? Let's take this glass bottle, right? You have the glass bottle, you have an almost empty bottle of ketchup, and then you have this picture. You see my book back there, right? So, let's take the glass bottle. I'm going to hit it, and you're going to hear different sounds. I'm hitting the top of it, hitting the bottom of it. See how the sound is different? With me even hitting it on the top. Even the bottom, though it's the same material, it sounds different. The bottom is thicker, and the bottom has an indentation. This indentation right here, I know you see the sticker, but it's an indentation right here, which causes a concave or a dent, which affects the sound of the bottle. The pitch. Let's take this plastic pitcher that is also empty, but it's bigger than the glass water container. You see that it's almost like a thud, whereas the glass container it sounds like a ping. Right? Let's see about the top. Now the top is made of a thicker material, a thicker plastic. So let's see about the top. And the top is more dense than the actual container. So the top is this blue part, right? Let's see. See how it sounds a lot different? The pitch is higher. And then even on the side, it goes back to that thud. Let's see if we can see if we have a different sound in the conclave. So it's almost like the top, and the side is different. So that is all in the pitch of a sound. Let's try this. Now, the plastic of the Heinz ketchup bottle is different from the plastic that's made of the pitcher. As you can see, different. Okay, let's see. You see how it makes that, it's like a thud, but it's also like a, you see how it sounds? It sounds quite different. Then at the bottom where there's ketchup inside, so it almost sounds empty up here, which it is. It's nothing. It's nothing in the inside of that part. So it's empty up here, and down here it sounds a little stronger. So up here, let's see about the top. Ooh, really louder than, and it's way louder than down here. And then on the top. Okay. So, pitch has a cousin, right? And that cousin works tirelessly. That cousin is volume. Volume. How loud or low we hear it, the more energy in the sound. So, the more energy that's in the sound, the more vibrations, the stronger the energy in the sound is, we hear it louder. So the less energy, it projects lower. The sound is lower. Okay? Then volume has a sister named amplitude. Amplitude is the height and wave measured from the midline. So remember, the midline is measured in the midline. The higher the amplitude of the wave, the more energy it has. So remember when I said that the more energy, the higher, the more we hear it, the lower the energy, the less we hear it. So I am going to play a familiar video for you.
Bass is in the middle of the drum, tone is at the edge.
That is Baba O playing the drums.
Using the palm.
So now I'm going to lower it down.
Let's try just bass. Quarter notes. Bass, 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 tone, bass, add the tone. Bass, tone, bass. That bass never.
Now, you might say, I could barely hear it, Mr. T, what are you doing? So, because I lowered it down, it just changes the volume of it, how we hear it. But it never changes the pitch. The notes that he is playing, the bass drum, bass. It's still playing as, it's still the same pitch. As you can see, right? So, when you lower it down, you take you take in more and more energy. You add energy, you're taking away energy. You add energy, take it away. Okay, so I might have that playing in the background. We get a little music while we learn. Now let me take some energy out of it. That way it's not distracting us. Okay, so you have a few questions. Inside of your assignment, you will see this picture. You are going to label the parts of this wave, okay? I want you to label the parts of the wave, and you have questions to answer. Remember, please make a copy of the actual document. Make a copy of the actual document, and you guys will be able to make a copy, download it, and then work from the copy, and then you'll be able to upload your video. So inside, you have a few questions, but I want you to answer the first two in video form. So your first question goes a little something like this. Let me turn the camera on myself.